Welcome to The Explainer. Today, we're going to tackle a topic that sounds super complex but is really about one simple thing: tidying up your data. We're diving into database normalization, which is just a fancy way of saying we're turning digital chaos into clean, organized, and super efficient information.
Okay, so here's the game plan. First, we're going to meet the villain of our story. Then, we'll uncover the secret weapon we need to fight it. After that, it's a three-step process to get our data in shape, and we'll wrap up by looking at why all this work is totally worth it.
You know, every good story needs a villain, right? Well, in the world of databases, our main villain is something called data redundancy. It's basically when you store the same piece of info over and over again in different places. And trust me, it creates a real mess. Let's go investigate the crime scene.
So, take a look at this table. You see the problem right away, don't you? See how the address for branch B003, 163 Main Street, Glasgow, is listed 3 separate times, once for Anne, once for David, and again for Susan? That right there is our villain, redundancy, caught in the act. And while it might not seem like a huge deal, it causes some serious headaches down the line.
And this redundancy, well, it leads directly to these nasty little traps called update anomalies. They make managing your data a total nightmare. For instance, you want to add a new branch. You can't, not until you actually assign an employee to it. What if the last person leaves a branch? Poof, the branch's record just vanishes from the table. And maybe worst of all, if a branch moves, you have to hunt down and change that address for every single employee. If you miss just one, your data is officially inconsistent.
So how in the world do we fight this villain? We use a powerful process called normalization. And the key to unlocking normalization is finding the clues hidden right there in the data. These clues are called functional dependencies, and they're going to be our hero's secret weapon.
Just think of it like a simple rule. It means if you know the value of A, you can figure out the value of B with 100% certainty every single time. For example, if you know unique employee ID, that ID determines their name. This simple concept is the fundamental clue that a database designer uses to bring order to all the chaos.
Now, it is absolutely essential to get this. It's a one-way street. A staff number, like SL21, will always point to one specific position, in this case, manager. That's a solid dependency, but you can't go the other way. Knowing someone is a manager doesn't tell you their unique staff number, because you could have lots of managers. Understanding this direction is the key to this whole thing.
All right, with our secret weapon in hand, let's start the investigation. Our first move is getting to the first normal form, or 1NF. This is step 1, the foundation for everything else, and it's all about getting organized and getting rid of messy, repeating groups of data.
The rule for 1NF is actually super simple. Every single cell in your table can only hold one single value. No lists, no items separated by commas, just one piece of data. I like to think of it like organizing a messy closet. 1NF is basically taking a giant pile of clothes and putting each item on its own hanger. One item, one hanger. That's it.
Okay, so here we have a table with client rental data that's officially in first normal form. We got rid of any repeating groups, and every cell has just one value. But our old villain redundancy is definitely still lurking around. The client's name is repeated, the property address is repeated, the owner's name is repeated. So while we're more organized, we are not efficient yet, not by a long shot. Our detective work is just getting started.
Time for step 2 in our big cleanup. Second normal form, or 2NF. This step tackles a really sneaky problem called a partial dependency. And you only run into this kind of issue in tables that have a composite primary key. That's just a key made up of 2 or more columns, like that client no property no key we just saw. What this really means is that every other piece of information in that row has to be about the whole key. It can't just be about one piece of the key. So in our client rental table, every column should be describing the specific rental agreement between that client and that property, not just info about the client or just info about the property. And our detective work turns up some big clues. The client's name, CNAME, well, that only depends on the client number part of our key. It has nothing to do with the property number. And it's the same with the property details. The address and the owner info only depend on the property number. These are partial dependencies, and they are breaking the rules of 2NF.
So what's the fix? Well, we do the logical thing. We break the table apart based on those dependencies. We make a new client table that only has client info. We make a property owner table that only has property info. And we keep a lean rental table just to link them together, which only holds data that depends on both the client and the property.
See? So much cleaner and way less redundancy.
We are so close. We've gotten rid of the repeating groups and those partial dependencies. The final step on our journey is reaching third normal form, or 3NF, and it's all about dealing with one last, kind of subtle, hidden redundancy.
Now, I know that sounds complicated, but there's this awesome little mantra to remember it by. Every non-key attribute must provide a fact about the key, the whole key, and nothing but the key. Basically, it means all the information in a table should be directly about its primary key, not about some other column that happens to be in the same table. So, if we look real close at our property owner table, we spot our final clue. The owner's name, OName, isn't directly about the primary key, property no. Instead, the property node determines the owner no, and then the owner no determines the OName. See that little chain reaction? That indirect relationship is called a transitive dependency, and it's the last bit of mess we need to clean up.
And you've probably guessed the solution by now. We split the table again. We create a brand new owner table that contains only information about the owners. Now, the property for rent table only holds info directly about the property itself. Each table is now about one single clear subject, and that is the absolute essence of a well-normalized database.
So, after all that detective work, after following the clues and splitting up our tables, what did we actually accomplish? What's the big payoff? Let's take a look at the final, beautifully organized result. And here it is, our final result. We started with one huge, messy, redundant table, and by following the rules of normalization, we've broken it down into 4 clean, logical tables. Each table describes exactly one thing: a client, an owner, a property, or the rental that links them. Case closed. So what does all this really mean for you? It means we have completely defeated the villain of data redundancy. Now if an owner changes their name, we update it in exactly one spot, the owner table. If a property's rent changes, we update it once in the property for rent table. Our database is now so much easier to maintain, it takes up less space, and is protected from all those nasty update anomalies we saw at the beginning. And that brings us to one last really interesting thought. Normalization is without a doubt the bedrock of traditional relational databases. But today, we live in a world with NoSQL databases and these massive unstructured datasets where sometimes these rules are intentionally bent for, say, performance reasons. So the big question is this strict organization always the right way to go, or are there times when a little bit of mess is actually a good thing? It's definitely a question worth thinking about. Thanks for diving into this with me.